Hello again, it's Richard Smith, and the second one of a sort of in brief series to try and explain some of the sort of tech that's going on these days. And this one is about how to save money by effectively doing simulation, by using synthetic data, in this case for robotic vision and robotic picking. So this is an area that you can save a whole bunch of money, tens of thousands, hundreds of thousands. You can save a bunch of time, effort, frustration, so that you create stuff in the lab, so that when it gets to the point where you go to the field, you have something that you've started with, that you've been able to train a model with without having to do too much real world testing. Although you can never escape the real world testing, it will happen. Anyway, so this is just a robotic video off the web of a robot picking from one bin on the right and putting it into the left. And this is sort of typical. When you have a model and you have a software, you're going to have to do this real world testing. This has traditionally been how things have been done. You actually set up the real world test and do it. But I'm going to talk today about an alternative and just try and explain it in brief, as it said. This is a simulation environment. It's from Unity. It's called Unity Perception. It's sort of experimental, but there's other companies that do something very similar. But what you here have, you've created objects that are real counterparts of real world objects. Here's one, for example. It has been scanned in or modeled and textured, so it looks like the real world equivalent. And what you can do in these environments is, just like you did in the bins for the robotic picking, you can sort of place them in the environment, point a camera at them, virtual camera, manipulate them, and record that information, and use that information to create your machine learning model, to feed your machine learning model. In this case, this software has a bunch of things called randomizer, so you can place the objects in a scene, and then you can randomize the scene and take an image, randomize it again, take another image. And that's what we're looking at here. So this is slightly weird. So what you've done is you have the products in front of an arbitrary, crazy background. And the reason you're doing this is you're going to challenge it. So this is what the camera view would be. Just imagine this is the real world boxes and some background. But you're going to do a simulation, and you're going to, I'm going to start it now, and it will sort of flash for a bit. But you can see here that the items have been put in different orientations, different rotations. They have this background, and the idea is capture this image and the data, and you can use this. So instead of having to jumble it in a box in real world, you can use this. Here we've just changed the lighting to make that variable as well. So in this virtual lab, you can create as many of these scenarios as possible. What happens is then it captures a frame, it captures an RGB, a picture, it captures a segmentation, so where it has found the objects. This is the segmentation view. And all of these things are annotated. So you hear that in machine learning vision, you go, we got some data, we looked at it, and we said, this is a tub, this is a box. And this is what this is automating. And it's helping to sort of keep humans out of the loop on it, so that you can get a whole bunch of data and use that to feed. Now, like I said, there's no substitute. You're going to the real world at some point, so be prepared for that. But here's a close-up of the image. You can see here, this is what's fed into the network. It's found different items and the orientations and colorized them. In this case, there's arbitrary colors. But I now have a set of data that I can actually use. And one other great advantage of doing this is, you may be going for some dead ends in research, and good to find about here. Here is the output data you get from it, a bunch of JSON files, but a bunch of data. There's a camera file that's just saying there's only one camera in the scene, but you need to know that for models. There could be more than one. We're going to look at sort of the annotation definition. So this is, what did I say were the objects I was interested in and looking for? And then here is the captures. And so when I found something in that image, I have to label it, just like you do with other machine learning. I found it, I found the box at these locations. The bounding box around it is this certain dimensions. And this is what you're looking for. You've had to do that in a manual way before. It's not perfect for everything, but it is an option and something you and your team should look at if you're not already doing this. Unity Perception happens to be the package, but there are others that do the same thing. And you can create synthetic data. That's what you're really talking about. It could be for cars, it could be for simulation, it could be for piece picking. So in summary, why should you look at this? You are going to, during any development, have to learn. You're going to iterate. You're going to do a lot of different tasks before you get to a fully fledged, working, successful product. And in the case of machine learning and training models, getting the data, it needs a lot of data, high volumes of it. And that is a tough exercise. It takes time, takes effort, takes money. Whatever you can do to shorten a workflow, like doing something like this, creating a synthetic data, that will save you time and effort. So again, that's it. Save it. You will get to the real world. You have to go to the real world. There is no choice about that. But you want to as well, right? That's the exciting part. Come from the lab into the real world. But here you have an option. So again, thank you for listening. I appreciate it. My name is Richard Smith, and I'll talk to you on the next one.